This week we're going to look at the normal model, or sometimes you can just say this is the normal distribution. But before we do that, I want to look at an observation that's going to be very important in this class. And when we do this, again, it's not going to make a lot of sense at first, okay? So one thing we want to understand is in statistics, we deal with data, and in order to organize that data, we can summarize numerical data by taking an average or a sum, for example. There's other ways of summarizing data, but we're going to focus on these two, which are very much fundamental summaries that other summaries kind of extend from. Now, there are two distributions we're dealing with here, and this is the thing that you want to start thinking about and recognizing. The distribution that our data comes from, we can think of that as a population distribution. And the distribution of all the possible summaries that could have been generated when we sample. Okay, and this one is the one that we are really interested in at the moment. The one that summaries that could have been generated. Okay, now you would think, well, why don't we look at the population? Isn't that important? And the answer is yes, it's very important. But the only way to understand anything about the population is to look at the summaries, or the only way to make decisions is based on the summaries. So the summaries play a huge role in you making a decision. So what we're interested in at the moment is that what does the distribution of sums or distribution of averages look like for different sample sizes? Okay, and as the course progresses, you'll see why this is so important. So we're going to do a simulation here. Okay. So here is a Google sheet, and what this is about to simulate is tossing a die, a six-sided fair die. There's nothing really particularly important about tossing a six-sided fair die. It's just that it's something you can imagine and visualize, and that's the only reason why we're doing this. But that's all data is, right? Data, it comes from just taking measurements. The types of measurements come from numbers. I'm going to go ahead, and you'll notice that there's this little number here. When you can follow along as well, but when you do this, just remember, don't mess with this first box, because you can see that this first box, I have it coded. And what we're going to do is you're going to go click on that box. Don't type anything into it, but move to the lower right-hand corner, like I'm doing right here. And you see this little target. You hit that, and now I'm holding the mouse as I'm hovering over that. I'm holding my mouse button down, and then I'm going to drag. And when I drag, you notice what the computer's about to do is enter more numbers randomly. So this is a ran between. What it's doing is choosing numbers between 1 and 6 randomly. So the result of a fair die, and it did it. So now I'm going to continue because I want to populate this whole thing with lots of numbers. So I'm going to come back here again, hold my mouse button right over that, and then hold my mouse button down, and now drag down. How many times? Well, we're going to go for a while here. We're going to go to, I think it's 3,000 where I wanted to go. So I might skip this later. But you see on the numbers on the right there, they're going down. And yeah, it's going to take a little bit of time. Now I'm going to push my mouse button down to make this go faster, but it's still going to take some time. So I'm going to just pause the video, and then we'll resume when this is done. Okay, so now I'm done, and I've populated this entire sheet with results from a fair six-sided die toss. And you notice I stopped here at line 3011, so there's 3,000 rows here. Okay, so now I'm going to we'll grab my mouse, and I'm going to go to the top again. Boom. Okay, here we are. And you see there's 20 columns, and there's 3,000 rows. Okay, the rows represent different tosses of size, whatever I'm going to decide in a minute. Okay, this is the iterations, the number of time I have tossed a die. The columns represent the sample size, the potential sample size, because I want to do different sample sizes. So the first thing I want to do is just verify that this computer did indeed randomly assign or toss these die, and it looks pretty much what I'm expecting it to look like. What am I expecting it to look like? Well, if you ever toss a six-sided fair die, it should all look nice and even, right? There's the same 1/6 chance of coming up a 1, 1/6 chance of coming up a 2, and so on. So again, I'm going to grab one of the columns. It doesn't really matter. I'm going to grab the column first one because it's just sitting here. It's convenient for me to grab it, but you can play around and grab any other column you want. I'm just going to grab a column because what I'm going to do next only works by selecting columns. That's why I also did 3,000, because this will give us an extremely good representation of what's happening here. In fact, I don't need to go any further. I'm going to stop right here. That's perfect. So I got about some 2,300 or so data values. Now I'm going to go to insert, once I got this column highlighted, and I am going to go to chart. And this is not what I want. But what it says here, chart type, column chart, that's not what I want. I'm going to scroll here to the bottom until I hit this one, which is the histogram chart. So that will group all of the data values into something. And you can see, there we go. There's the ones, and you can see there's the number 2 shot, number 3, 4, 5, and 6. And you can see it's pretty much the same all the way across. Okay, and you can see there's between 1 and 2, there's nothing. Between 2 and 3, there's nothing. Between 3 and 4, and so on. This is a result of a die. So now we're going through this thing. The distribution we're sampling from is what? Well, this distribution, because it's even, it's called uniform. And because all I can get is a 1, a 2, or a 3, or 4, or 5, or 6. In other words, it happens in jumps. So I cannot get 2.34567, for example. I cannot get any number between 1 and 2. Because of that, this is called discrete. The data happens in jumps, and there's gaps all over the place. And each number is kind of isolated from every other number. Unlike something that's continuous, that means that you can get any number next to any other number. It's possible. Okay, let me go back. So now you see what this thing looks like. This is called the parent population. As a matter of fact, I'm going to go back here one more time, and I'm going to make a little picture of this. So I've created my little picture here. I just, you can do this and copy this on your own. But this is what the distribution looks like that I'm sampling from. So the population distribution, sometimes also known as a parent population, because of what we're about to do next. Well, one thing you'll want to also understand about statistics is that we have a lot of different words, and it's a lot of slang that goes around to try and capture what we're doing. So now we're going to go back to this thing, and what are we going to do? I'm going to go back here. What would happen if I sampled twice? So I know I sampled here 20 times, so I'm only going to grab, notice when I come here and I click on this thing, which is the average, I'm only really averaging these two numbers. So I got a 1 and a 3, and that averaged up to 2. And that's what the result of that. Well, I also sampled 4 here. And what would happen if I sampled 4? Well, notice I got 1, 2, 3, 4 numbers. You can grab anything you want, just grab 4. And the way that I'm calculating the average here is by typing equal to average parentheses and then highlight whatever I want. So for example, for this one, 20, I just highlighted everything. So it would look something like this. Again, type equal to average on top and then highlight all of them and close it and then hit return. Again, my computer is very slow. So I got to do it for this one. Nope, almost did it for the other one, but it didn't click. No, there it is. I had to, again, my computer's super slow. It's old. So there we go. So you'll notice different averages. Here's for averaging 2 numbers. Here's averaging 4 numbers. This is averaging 10 numbers. And this is averaging 20 numbers. And this is all random. So your numbers, when you do this, if you want to do this, will come up with different numbers here. But what we're interested in is what happens when the distribution of sums. That's what we're going for right now. Distribution of sums. So this is just one single. When you do this, I could have got 2.5, but you might have got something else. That's just a single result. What we care about is all possible results. However, we cannot do this forever, and we're trying to simulate so we don't have to understand any theoretical probability. All I'm going to do is just doing this simulation to get a good idea what's happening. So now I'm going to highlight all these 4 rows, and I'm going to go down and just, select, hold the mouse button down and drag, because it's about to calculate different means for different rows. Okay, again, I'm going to pause the video until I get to the bottom. I'm at the bottom here, and I've finished. I think I had different averages depending on what things I'm averaging. Okay, I'm going to move back to the top. And so let's look at what these distributions look like. So I'm going to grab this first column and highlight it. Okay, I'm going to have to edit this. It's going so slow. So again, I'm going to go back to insert, chart, and then select from the charts. This one says histogram, and there you go. So you'll notice that I went from this uniform looking graph, but averaging 2 numbers, this averaging 2 numbers at a time, created this pyramid looking thing. And actually that's what it looks like if you were to do a theoretical approach. You'll notice this pyramid is not perfect because it's all, again, random sampling, but it's so much random sampling that it gives you a very good idea what the actual distribution looks like. So yes, indeed, that's what it looks like. It looks like this pyramid looking thing. Notice I've created a little picture here as best as I could. This is now, what I've created now is a little different. This is going to be distribution of means. For n equals 2. So these are just averages of 2 numbers at a time. And you can see now, if you look closely, that there is something in between. So before there was only possible 1, 2, 3, 4, 5, 6. Now it's possible of 1, 2, 3, 4, 5, 6, and things in between. So 1.5 is possible, 2.5 is possible, 3.5 is possible. So go back to the other chart. Notice right here, there's 1, there's 2, there's a 3, but there's things in between because I'm averaging 2 numbers now. So I've increased the number of possibilities. That's another thing just to notice when you do this, even though you're only started with 6 numbers to begin with. Only 6 numbers are possible, but you sort of like doubled what is possible once you sample twice. So here's the thing that I goofed up. I want to talk about sums first, but it looks like I'm talking about averages, so it's okay. We'll do this backwards. So this is going to be the average part, okay? But the sum is next door, and I want to just address that real fast. So what is a sum? An average is just taking the 2 numbers, adding them together, and dividing it by 2 in this case. But what's the average? Well, the sum is just going to be the sum of those 2 numbers. So for example, if my average is 3.5 and I'm only averaging 2 numbers, then my sum is just going to be twice that much. I went over here and said, look, give me this value and just multiply times 2. So I pointed to that thing and just double that, and you get 7. And if we go back to what I averaged, notice the first 2 numbers that I'm averaging here, let me kind of highlight, is a 5 and a 2. 5 plus 2 is indeed 7. So I'm going to really quickly do the same thing. I'm going to highlight all of this and drag down, but I'm going to pause the video so I can get the rest of these sums. Okay, so I've got here to the bottom. I got all my sums, and I'm going to just click here, highlight, and move up. I'm going to just the easiest thing to do. And then I'm going to come over here to, again, insert, chart, and then select. So histogram here at the bottom, and here's now the sum. And what's the difference? Well, notice, I think it's the same picture. If you put them side by side, you're going to get exactly the same picture. I mean, literally the same bumps, everything's the same. What's the only difference? The axis here. Since these are averages, this is like a 1, but an average of 1, if I sample 2, is really a 2. This is about a 1.5, but if I double that, it's really a 3. And again, you can't see that because it's not showing you the 3, but it's supposed to be a 3. Can I do that? Can it will show me? Nope, it won't. Here is again, yeah, notice this is a count between 3.89 and 4.10, but that's really a 4. These are nothing but 4s, which came from the 2 right here, and so on. So this is between 6.83 and 7.0, which is really a 7. This is a bunch of 7s we got, which came from this 3.5. Really, whether you average it or sum it, it's really the same thing, except here's the thing that I always pitch. You've seen the old Crest commercials, like 7 out of 10 doctors prefer Crest. Well, 7 out of 10 is like a sum, versus 70% of doctors prefer Crest. Well, the 70% is really just an average. Like 7 said yes out of 10, so 7 divided by 10. So it's an average. Well, sum is a perfectly good summary. It's easier for us to comprehend if we convert it to an average. But both of these are the same summary. Not exactly the same summary, but you see what I'm getting. They're connected. Once you get one, you know the other one. So we got this one, so now let's figure out the rest of these. So for sakes, I'm not going to do the sums. You can do this on your own. I'm just going to save some time. It's taking too long. So I'm going to grab here and create a chart for this one and see what it looks like. I'm going to pause the video. Again, insert, just like chart. I did that. Now I'm over here in chart, and I need to just select histogram. And you go, oh wow, that's a nice looking graph. And now what am I doing here? I'm averaging 4 numbers, if I remember correctly. Yep, I'm averaging 4 numbers. So let me just do this one more time. Just insert chart, just so I don't have to grab it from the bottom. So there's the 4. And what do you notice about this one? Again, notice here's the 6. 6 is somewhere here. There it is. There's one. Looks like I only got 1, maybe a 1 out of 6. And notice I got 0, 1, which is hard to do, right? Because in order to come up with this, I saw if I want to get an average of 1, they will all have to come up with 4 ones, and that's the only way I can get a 1. So you'll notice now that becomes a little harder to do. I did it 3,000 times. You think it would have happened once, but it didn't. But it did happen that I got 4 6s, and that did happen. Maybe once, maybe twice. I can't tell. Count how many rectangles are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then, but now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the number of possibilities just jumped. It was rough, but it looked at the shape. It went from a triangle, so it now looks a little less like a triangle. So let's keep going. Let's get to the next one. And if I did the sum one, it would look exactly the same. Okay, it's same shape, except the numbers at the bottom would not be the same. For example, this one ended at a 6, but because it's 4 times that amount, this number would end up at 24. So 6 times 4 is 24. I'm averaging 4 numbers, so now I'm going to grab the 10 one. Well, now that I grab the 10 one, if I'm doing a sum, the maximum I can get as an average is 6. That would mean all 10 values resulted in a 6. So when I average those 10 values, the average would be 6. So on the other side, the sum would be 60. But what's the chance of tossing 10 die? All of them land on 6. And the answer to that is not very good. Pause and create another chart. Right, so I'm in here. I'm going to now go again back to insert. Highlighted my averages of 10 numbers. Go to insert. Chart. Again, that's not what I want. I'm going to come here, click down on chart, and select histogram at the bottom. So notice that what's happening. Couple things to understand is, like, look, 6 is not appearing. Like, if I toss 10 die, is it possible that I get all 6s? The answer is yes, but is it likely? Like, no, and you can see here how unlikely this is. Same thing for the 1. Notice it's not even showing up, but I still notice it's also getting more filled in. I got now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. I mean, there's way more possibilities now that I'm averaging 10 numbers. I'm sure there's things missing because now it's grouping together. So I'm really not counting all the possibilities here at all, because things are getting grouped. But notice the shape is getting tighter, and it's looking like this mound shape thing. So we'll do it one more time. Notice I'm going to keep track of these. What I'm doing is the snipping tool. I can't get it on camera. It allows me to just grab a screen grab. It's completely off screen right now. So when I come over here, I can just paste and then resize it. And there it is. There's the other one. And this is for 10. You see them side by side. A lot more things. So this is the distribution of means for n equals 10. And just again, for time's sake, I'm not going to do the sums. I'm just doing the averages now. But the picture of the sums will be exactly the same. The shape is exactly the same. What's different is the numbers at the bottom. So this is an average, and the other ones will be sums, obviously. So we'll do one more here. So now I'm going to grab the 20, do the same thing, and create a chart. Okay, so I got to the very end here. I'm going to go back to insert, chart. There we go. And then select the column chart and select histogram. And this is what I get. Ooh, that's kind of interesting. So, but again, this is random. So randomness always, you can't predict what's about to happen here. But notice again that is it possible? I'm tossing how many? Tossing 20. So is it possible to get a sample average of 6? The answer is yes. But is it likely to happen? No, because 20 of the dice would have to land on 6. And you can see here, notice, I look at the bottom. The one thing you want to do is start reading the numbers at the bottom and just see what's possible. And you can see that like an average of somewhere around 4 is not that likely, right? But it does happen. Most of the averages are coming around the 3 range or so, 3 to 4 range, above 4, no good. And again, the computer just, when is aggregating things together, so you get these spikes. But the reality is that's just dumb luck. If you did it, you probably get a different distribution. It will look more like this one right here. The distribution of sums or averages start to create this shape. And what is this shape right here? This is a normal model. That's what's happening. I'm going to do this one more time.